Ever wonder why some developers are ditching cloud APIs and running their own AI video models? Self-hosting gives you total data privacy. Nothing ever leaves your infrastructure. Zero API costs, no subscription fees, no generation limits, and you're completely independent from cloud downtime or surprise model updates. Enter Mochi One by Genmo, a powerful 10 billion parameter text-to-video model built right in San Francisco. What makes Mochi One special? Its motion physics are incredibly fluid and natural, far less trippy than many early models. And it ships under the Apache 2.0 license, as open source as it gets. Let's get it running on your own hardware. To deploy Mochi One, we need a GPU-optimized AWS EC2 instance. Since it's a 10 billion parameter model, the G5.2X Large is our recommended entry point. That's an NVIDIA A10G GPU with 24 gigabytes of VRAM. For the operating system, we'll use Ubuntu 24.04 LTS with 256 gigabytes of disk space. Now, there is a more powerful option, the G7E.2X Large, but at $3.70 per hour, it's pricey. The G5.2X Large gives us everything we need at just $1.20 per hour, much more cost-effective. Here's an important tip before you launch. Check the top right corner of your AWS console for your region. If you're in US West 1, that's Northern California, G5 and G7E instances are often scarce. Switch to US East, Northern Virginia, US East 1, or US West, Oregon, US West 2. These regions have much better availability. Before we can run Mochi One, we need to set up the GPU drivers. Here's why this matters. PyTorch uses CUDA to offload heavy math, like matrix multiplications, from the CPU to NVIDIA GPUs. Think of it as a chain. PyTorch talks to the CUDA library, which talks to the NVIDIA kernel module, which talks directly to the hardware. The key is making sure all three match in version. On our AWS Ubuntu 24.04 instance, we align everything to the 550 driver series, the stable production standard for these cards in 2026. First, let's update the system and purge any mismatched driver bits. We run sudo apt update and apt upgrade, then sudo apt get purge NVIDIA star, followed by auto remove to clean the slate. Next, we install the consistent NVIDIA 550 server driver, utilities, and Linux headers, all in one command. Now here's the critical step. We must reboot. The kernel needs to load the new driver. Run sudo reboot, wait about a minute, then SSH back in. Once you're back, run NVIDIA-SMI. You should see a clean table showing your NVIDIA A10G GPU, the driver version, CUDA version, and memory stats. If you see this table, your GPU is ready to go. Now let's set up a clean Python environment for Mochi One. We'll use a virtual environment to keep the system clean. Even though Python ships with Ubuntu, the virtual environment module is kept in a separate package to keep the OS image small. To bridge the gap, we install Python 3.12 venv, create our virtual environment called venv-mochi, and activate it. Next, we link PyTorch to our GPU drivers. This command force reinstalls PyTorch, Torch Vision, and Torch Audio from the CUDA 12.4 wheel index, making sure our venv-mochi uses the correct binaries to talk to the kernel driver. Then we install the rest of our Python runtime dependencies. Let me quickly walk you through the key packages. Diffusers is Hugging Face's library for running diffusion models, and it has native support for both Mochi and LTX models. Transformers is the backbone library for transformer architectures. And OpenML has a dedicated article explaining how transformers work. You can find it at blogs.openml.io/posts/transformer. We also need FFmpeg to turn our model's raw output into playable video files. And with that, our environment is ready. For our final step, let's make sure we have enough memory. We'll create a 32 gigabyte swap file as a safety net in case our instance runs low on virtual memory. 4 quick commands: allocate the space, set permissions, format it as swap, and activate it. Now for the moment of truth. Here's the Python script that invokes Mochi1 to generate video. Take a moment to pause if you'd like to study or copy this code. And let's run it. The model loads its checkpoints and pipeline components. This takes a few minutes on our G5 instance. Then the generation begins. And just like that, here's our result. Video.mp4, generated entirely on our own hardware. No cloud API, no subscription. Just pure, self-hosted AI video generation. So here's a fun question for you. Are you able to tell what prompt was used to generate this?